Hi, everyone, and welcome to our webinar today. We're going to be talking about tackling our functional safety management challenges for the machinery industry. And so for the webinar today, we are going to be using the GoToWebinar application. So make sure your speaker is enabled in all places. And if you lose audio at any point during the presentation, let us know and we can help you try to troubleshoot and see if there's anywhere else it needs to be enabled. There's also a questions tool as part of the GoToWebinar application. And so you should see that over to the right of your screen. And so as we go throughout the presentation, please use that to input any questions as we go. We should have about 15 minutes at the end to answer questions. And for our topic today, we're going to be looking at functional safety management. And this is something that can apply whether we're talking about, product development, the process industry, or machinery, because ultimately we've got to look at managing systematic failures, making sure that whether it is a unauthorized change, whether it's failing to follow the proper procedure for a proof test or bringing in a piece of equipment back into service. There are a lot of systematic issues that could potentially defeat our safety functions and put us into a less safe condition. And so we have to have a robust and consistent way of tackling it. And so in 61511 in the process safety industry, we've seen a lot of focus on this over the years. But at least in some of my personal experience, I've seen that some applications or some areas of the machinery industry are still a little bit less mature when it comes to the safety management aspects. And so for this presentation, we'll look specifically at some of the requirements and guidelines for functional safety management in 62061 and ISO 13849, talk about really where that fits in with the rest of the machine safety lifecycle. And then we'll talk about some key concepts and best practices for implementing machine safety management and really trying to address those difficult issues there. And then lastly, we'll look at the new machine safety focused templates that Exida has developed and look at where those can sometimes be used as a starting point to really develop and implement that functional safety program more quickly for machinery. And so before diving into the details, I'd like to just give a brief introduction on myself and on Exida. So I am Patrick O'Brien. I'm a senior safety and cybersecurity engineer at Exida and have been at Exida for a little bit over 8 years now. And my background started in chemical engineering. So I certainly was originally involved much more in process safety risk assessments, PHAs, HAZOPs. But over time, I've gotten involved in a number of other focus areas as well, namely cybersecurity and machine safety. And so what I've seen moving from a traditional HAZOP or process hazard analysis and completing quite a few different machine safety risk assessments in different areas is that there are quite a few similarities where we can leverage and take advantage of what might already be in place from a process safety side. But there are still a lot of differences, and it's not a one-size-fits-all approach where we can just take everything from the process approach and expect that will give us good results on the machinery side. And so we'll talk about, again, maybe some of those areas where we can take advantage of what's already there, and then some areas where it's really important to understand the differences for machine safety and some of the keys of making sure that that gets implemented in a robust manner. And so for Exida as a whole, we are a customer-focused company that helps our customers to achieve safe, secure, and reliable solutions. And there are three main parts of Exida. There are three different ways in which we help do that. So the first part of Exida, where we were originally founded, is as a certification and assessment body. And so we are an accredited body to provide certifications to a number of functional safety and cybersecurity standards, including IEC 61508, IEC 62443 from the cybersecurity side. But we're also accredited to provide certifications for machine safety as well. So to the IEC 62061 standard and the ISO 13849 standards. And another thing to mention is that over the last year or two, Exida has also gone through the process of becoming a notified body, and that helps them to be a little bit better positioned to support some specific questions on the machinery directive in Europe, and looking at some of those other machinery-focused certifications. So if you do have questions on that, we have certainly more information that we can provide there as well. On the lifecycle services side, this comes down to tackling lifecycle tasks for safety, cybersecurity, and alarm management. And we do offer a full set of lifecycle services for machine safety as well. Everything from hazard and risk analysis through PL or SIL determination using a risk matrix or risk graph, all the way through identifying safety requirements, reviewing validation plans, and also helping really throughout the full life cycle there, doing your SIL or PL verification calculations and so on. And then lastly, from our enterprise tools standpoint, we have a variety of both software tools and other templates and reference materials. So our Excellentia software, which we a lot of times will use with asset owners to do everything from hazard and risk assessment through SIL verification and proof test generation, as well as template series like the IEC 62061 template series that we'll be talking about more in this webinar. And so as we dive into the details on our webinar, we're going to focus on three main areas. We will start by covering the trends and looking at really the machine safety adoption standpoint, where the industry is going, what are some things that we're currently seeing there. Next, we'll look at the place where functional safety management comes into play in terms of tackling those issues for machinery. And lastly, we'll look at some areas where templates can help with that in terms of helping with that deployment of the functional safety management for machinery and where we really need those templates to get started. And so what I like to start with and really understand is what is driving machine safety adoption? What are some of the key issues or questions that companies are trying to answer and address when it comes to machine safety? And so ultimately, for industrial facilities, whether it's a chemical plant, whether it's a machine application, it ultimately comes down to facility risk management. Companies want to provide a place that is safe to work. They want to protect their workers from harm and make sure that they're not suffering unnecessary losses for people, for equipment, for the environment, for all of those different reasons. And so when we look at what drives how we manage those risks and understand those risks, we can look at the impacts of different areas. From a national standards and regulations standpoint, the machinery directive, especially within Europe, has a major impact on how machine safety is addressed, both by the suppliers and also what operating companies are asking for or looking for in the products or systems that they purchase. And something that's important and interesting to note there is that the machinery directive over the next couple of years, I believe it will come into effect in 2027, will actually be moving from a directive to a regulation, so really having the weight of law behind it. And so that's something where we expect that to have some significant impact in terms of how machinery safety is handled in the European Union. And it's not just there. There are certainly a number of other regulatory impacts. Australia has some very strict requirements. And again, countries from Africa to Asia to North and South America, there are a lot of different specific regulatory requirements that need to be looked at from a machinery standpoint. In the United States, there are some general OSHA guidelines, so requirements for providing a safe workplace, which I'll often talk about and go back to that general duty of providing that safe workplace. And there are also specific subsections and requirements for machinery protecting against common machine hazards. And so all of those play a role in shaping how organizations look to address that risk. We can also think about the insurance requirements, and that's also something that tends to be important in the US for organizations that aren't self-insured. Insurance companies can either come in after an incident, after a claim, and really try to understand, is the organization following best practices? Is it a company that they want to insure, or are they maybe not following a robust approach, and is the insurance company taking on undue risk by insuring them? We also see that some insurance companies are doing proactive audits to really try to understand the type of program that's in place and make a determination of whether or not they want to insure the company in the first place. We can also think about the stakeholder expectations within the organization, looking at objectives for quality and safety improvements, and those drivers and those programs that as they get rolled out within an organization. That can also have a significant impact on how companies adopt safety as well. And then lastly, on the machinery side, there are a lot of application standards, different types of standards, from more general broad categories such as ISO 12100 for risk assessment, or looking at 62061 and ISO 13849 for how safety systems or safety-related control systems are implemented, as well as some very specific application standards to specific safety function types, specific machine applications that we'll talk about a little bit more, but those can be very helpful for identifying specific steps as well. And so in addition to understanding those drivers and those forces influencing adoption, it can also be helpful to take a look at what are companies maybe still holding on to for myths about machine safety. And so as I go through this list, I want everyone to think and see, have they heard this before? And some of them you may have heard many times, some of them you may not have heard before. But these are all things that I or other members of Exida have heard talking with customers about machine safety or as part of machine safety projects. So the first one, machine safety was handled by the equipment designer. There's nothing I have to do as an operator. This is something that I'll say is a much more common mindset in the machinery industry compared to the process industry. But there's an idea where if a company buys a system that complies with the machinery directive, that all of the safety functions will be pre-installed and that they can just let it run and they'll never have any issues with safety. But if the operators don't understand how those safety functions work, if they don't understand, let's say, best practices for operating the machine, if the safety functions require periodic testing, if unauthorized changes are made to the system, there are a number of things that can happen that will decrease the amount of safety and not necessarily reach your safety goals, even if you start out with a system that's fully compliant, provided by a knowledgeable supplier or integrator. Another one I've heard walking around and actually looking in the plant itself is if I ask why there's a moving part or a sharp edge or a pinch point that's not currently guarded, and just ask if they have thought about guarding there, a lot of times I'll get back, oh, that part doesn't need to be guarded. Everyone knows not to go near it. And so that may be all well and good on a typical day, but if someone's behind on time, if someone's having an off day, maybe not paying attention, maybe not as focused as they typically are, or a piece of equipment moves unexpectedly, someone drops something, all of a sudden that person may reach in, may be exposed to that hazard. And when you think about either the regulatory or the insurance review or even a legal review in the United States, saying that someone knew that was a hazard and that they shouldn't have reached there is not a defense against having guarding. So having that expectation that people know where the hazards are really tends to be one of those places where we put blinders up and don't really look at it for the potential hazard that it presents. This is one that I've also heard sometimes where there's this expectation or this idea that machine safety is just a problem for developing nations and that it's already been something that's been addressed in the US or in other countries like it. And we'll take a look at the data, but that really doesn't back that up. We've got some pretty significant continued accident and fatality statistics in the United States. And so this is something that is very much a problem everywhere where there are machinery applications. Another one we hear sometimes is that, oh, the operators have already been trained on the machinery hazards once. No one needs a refresher. This idea that safety is a single activity or a single point in time But we see time and time again that building a good safety culture, making sure that people are familiar with the hazard of the machines and that it's consistently refreshed is very important for maintaining that awareness. And then my last one, and probably my favorite one, and you can say this about anything, whether it's process safety, machine safety, cybersecurity, but we hear it all the time, and that is, we haven't had any issues before, so we must be safe. We must be doing everything right, and we've got nothing to worry about. And unfortunately, a lot of companies may keep that mindset until they get a major incident or a major accident, and realize all of the things that they could have been doing to maintain a safer environment from the beginning. So that's something that we definitely want to be aware of, those myths for the machinery industry. And the reality, though, is that machinery accidents continue to happen at a high rate. In 2017, there were over 36,000 injuries in the US alone. In 2018, there were over 6,000 non-fatal amputations, with the majority of those involving machinery and machinery applications. And in 2019, there were nearly 3,000 fatalities in machinery-related industries like manufacturing, construction, transportation and warehousing, and agriculture. And so we see, even though there's this idea that we've already tackled, we've already handled the problem, the incident statistics don't really back that up. And if we look at data points in the US from 2000 to 2018, we can see that although there is some slight downward movement overall, if we average all industries, if we break up the data and look at each industry independently, maybe outside of construction and mining, where there was a noticeable drop in incidents between 2000 and 2010, the majority of other industries are actually staying pretty flat or constant, and actually even seeing some increases in agriculture and transportation. And so the reason that I highlight this is, although if we track the data back to the 70s and the 80s, we can see some improvement from then to the 2000s. What this is saying is we're not on a constant downward trajectory for machine safety incidents, and that although we've had technology improvements, we've got better safety PLCs than ever before, more advanced systems, more advanced tracking than ever before, we're not necessarily any safer than we were 20 years ago, or we're not significantly safer than we were 20 years ago. And so I'm not saying that what I will propose here is a total answer or a complete answer to this problem, but I think it definitely falls in as a piece of this. And that is that having a machine safety program, actually managing it, making sure that the risk assessments are done robustly, making sure that everyone at the site or facility is familiar with them and understands where the hazards are, and not just covering it once, but having refresher training, making sure that you've got change management in place so that if changes happen, you can assess the risk for those, make sure that they're adequately reviewed and handled. All of that, and really that machine safety management piece, and the ownership of that risk, I believe is one of the critical pieces of continuing to try to reduce this risk further, and make and maintain safer facilities. And so that's something that we'll focus on and really look at in this webinar. And so if we think about that current state of where we are, and then ask the question, well, how can a standard help with that? What does a standard give us that can help us be more safe? The first piece is it documents industry best practice. So we've got a collection of industry experts. We get an idea and an understanding of what typical best practices are, what should be followed. We can see consistency across multiple organizations. What are the manufacturers doing versus the system integrators? What do the end users or the final asset owners need to know? And so it can help us really identify and say, okay, if we ask for a SIL 2 system, that means the same thing to the integrator, the end user, and the product supplier that's looking to develop a SIL 2 component. Also, if we follow a step-by-step lifecycle approach, we're less likely to miss a key activity because we're going in a consistent pattern. And then the last one, common or known mistakes are explicitly addressed. This one is particularly important for the machinery industry because with all of those application that machine type specific standards, a lot of those common or known mistakes are explicitly called out in terms of common hazard areas, specific scenarios to look at in the risk assessment, typical guarding strategies for them. And so that can be really beneficial in taking a base machine and adding some significant safety features onto it. If we take a closer look at the 62061 standard, we can see that this follows a similar life cycle approach to either IEC 61508 or IEC 61511, where we first have an analysis phase where we need to understand what the hazards, what the risks are, thinking about the risk assessment, looking for machinery specific hazard. Are there pinch points? Are there sharp edges, crushing points? And really making sure that we understand the hazards that we're trying to protect against for the system. From there, we can identify risk reduction measures, whether it is a physical guard or some sort of safety function. And then from there, going in through the design and realization phase, looking at what we need to do to operate and maintain that equipment over time, and validating it when we install it. And so we still can think about going through those three main phases: analysis, design and realization, and operations and maintenance. And still having that consistent approach for 62061. We can also look at management of functional safety, making sure that we're doing the right things at each step, that we have the right documentation. That's something that spans the entire life cycle. And again, is really where having that robust program comes into play and is very important. If we look at things from an ISO 13849 perspective, the specific steps or the orders and the way we work through it is a little bit different, but it still follows that same general thought process of starting with that analysis piece to understand the hazards and the risks that we're protecting against in the analysis phase, and then going on and looking at designing, implementing the correct safety functions to address that in the design and implementation phase. 13849 is a little bit weaker on the O&M phase, but we'll talk about some of the key places where that comes into play and is still important for the machinery industry. And so when we take these standards, we take this life cycle approach and think about effective implementation. How can we take those best practices and really fit them into our environment or our organization? The first thing that a lot of times we recommend is a benchmark study. And here we can think about understanding where the company is now as a starting point. Have they been implementing machine safety for years and just have a couple of maybe areas where they have some room for improvement and can make some adjustments or some tweaks? Or is this a company that hasn't had a strong program in the past? And is there anything that we can leverage as we start to build a new one? So understanding where you are, how far away your current starting point is from your end goal is very important in building that strategy or putting a roadmap in place. So we might call that a machine safety roadmap, where you figure out exactly what you need to do, what programs, what policies, what changes you need to make to get from point A to point B and really make that improvement, make that progress. And so a lot of times that functional safety management plan, actually documenting the procedures that you're going to follow, is one of the key first steps in that roadmap, because it then gives you a consistent method and manner to actually go through and implement the life cycle, to do the system design and make the changes where it's needed, to do the proper validation testing when implementing the safety functions. And lastly, to think about what needs to be done to maintain the system in a safe state over time. And so when we start with the benchmark study, there have been quite a few typical machine safety gaps that we see with different organizations that we've worked with. So the first one, a lack of a structured process where there's really not much, if any, documentation on the asset owner side for maintaining the system. So they may have an expectation that they will receive a system from the integrator that's fully compliant, and they don't have anything documented about what they do with that system from there. Another one we see, and I'll admit that this is a little bit of a personal pet peeve for me, is that there's not often agreed tolerable risk criteria for the organization. And this is something that really has to be understood and accepted by the organization because it deals with how much risk the organization is willing to accept or take on. And in IEC 62061, there is a risk matrix that can be used to compare the consequence severity and the class, which is a combination of different factors on likelihood, to estimate the risk and see what sort of SIL level is expected to move from that current risk to a tolerable or an acceptable risk. And similarly, in ISO 13849, there's a risk graph that is commonly used to identify what performance level is required. But what a lot of people don't realize when they use those references is they are informative parts of the standard. So there's nothing in 62061 that says you must use this risk matrix when determining your SIL level. There's nothing in ISO 13849 that says you must use this risk graph when determining your performance level. And so a lot of companies are buying into whatever risk tolerance criteria is used in that reference in the standard without really analyzing it and understanding, do the assumptions they make in 62061, does that line up with your organization's risk tolerance? Have you set targets for serious injuries or potential fatalities? And that's something that, again, really understanding where those risk targets are is important for each organization. And it may be different from what's in the standard because that organization may have a different risk tolerance, may be willing to accept more or less risk than typical. And that may lead to differences in the design compared to the standard. Or differences in the target, I should say, compared to the standard. Some other typical issues that we see are poor communications across organizations. So looking at that poor integrator or system provider handoff with the owner operator, not having complete documentation, missing procedures, missing risk assessment reports, missing validation and test reports. All of those are pretty common trends. We also can look at a lack of change or configuration management. And we've got a specific case study on that I'll jump to on the next slide to talk about that in a little bit more detail. But this is a major issue I've seen with a number of machine safety applications. Some other ones in terms of the specific safety function implementation, having non-SIL or PL rated equipment without providing the appropriate justification, basically demonstrating that the systematic capability is sufficient for the system, similar to a proven use justification on the process industry. There are some design principles and practices that need to be followed, that need to be validated. And so really, again, using SIL and PL rated equipment can certainly help with that. And then incorrect SIL PL verification calculations, incorrect assumptions, incorrect or overly optimistic data points. So all of that can also lead to an expectation that the facility or the machine is a lot safer than it may actually be. And then the last one, and another one I'll say that's a bit of a point of emphasis for me, is the fall off in the operations and maintenance phase. So very often we see either no periodic testing or very infrequent or unstructured periodic testing. The amount of times I've seen someone test a light curtain by sticking their arm through the light curtain into a hazard zone to see if the machine stops is more than I'd care to admit. That really doesn't count as a true proof test. There is a bit more to it than that. We've got to document, we've got to test it in a safe way. Also thinking about the useful life for components, where a lot of machinery standards assume a 20-year life of the machine, but that may not be the useful life for that individual component. And in particular, we see a lot of times with hydraulic systems or pneumatic systems that a solenoid valve may only have a useful life for certain components of 3 years. And if we're relying on that to act for a safety function, we install it and are going to run it for 20 years, that safety function may have components that aren't going to work anymore. Additionally, even though ISO 13849 doesn't require testing of all safety functions, if you do have hydraulic components or other pieces that can have things like stiction and additional failure modes that occur if it sits for a long period of time, there are actually requirements in 13849 that those need to be stroke tested at least every 2 weeks in order for the failure rates given as estimates and other approximations to be valid. And a lot of times those are the pieces of fine print that often get missed. And again, you may have companies running with something that they expect to be perfectly safe, where the safety function has failed and has been failed for years and had never really been tested. They didn't understand that it needed to be periodically moved or jogged to make sure that those hydraulic components were still working. And so if we go back and take a look at the change or configuration management piece, this is a story from one time when I was providing or presenting our machine safety training course. And when I got there, the site was all excited. They were feeling confident. They had a relatively new, fully rated PLC. It had only been on site for 2 years. All of the SIFs were installed. They had been tested, so verification calculations were done. The integrator was very knowledgeable and gave them this fully compliant system to start. And so we start going into the training course, and as we go through each day, we find out a little bit more about the system. So the first thing we found out is that access to making configuration changes to the safety PLC was not restricted at all. The accounts needed to make changes were essentially open to everyone, whether it was controls engineers, whether they'd been trained or not, even some of the, I'll say, more involved operators and maintenance technicians who are familiar with the system had the account and could make changes. So we really weren't restricting or controlling those changes. Find out a little bit more, there also wasn't any configuration or change management process that had been followed. So there was no formal place to document changes. There was no formal process for understanding whether or not a change could have a safety impact. And finally, by the last day, we realized that dozens to hundreds of different changes had been made to that safety rated PLC in the last 2 years. No documentation, no information about what types of changes have been made, who made them, any of that. And so really, you do all of this work up front, you get this fully still rated compliance system of all of the safety functions in there. And in less than 2 years, could have even as soon as a month or two, a whole bunch of unauthorized, untracked changes have been made. You have no idea whether or not the safety functions are still active, whether or not they're still effective the way they were designed. And so you really now lost all of that safety benefit for the site until you do a full review of the logic, until you retest, revalidate everything, and implement change control. And this was a story from one site, but I guarantee you that this is much more common than you think. And all it takes is one change or one bypass of a safety function for that safety function to no longer be active, no longer be effective. So this is one area where having that functional safety management program, having the change management, having the configuration management in place is so important. Because even if you do everything right up front, if you don't manage changes, you're losing all of that benefit. And so if we look at these typical safety gaps overall and talk about just like that, how can we really try to address them? The majority of the gaps can actually be explicitly addressed in a top level machine functional safety management plan that covers the process, that covers what's done. From some of the specific lifecycle tasks like configuration or change management, doing the PL or SIL verification calculations, documenting the maintenance requirements, those can then be specifically addressed by group procedures that essentially outline exactly what needs to be done there. From a machine safety management perspective, or what are really the goals that you're looking to establish, building a company safety culture, building the awareness of the hazards, building the buy-in to do things right, do things consistently. is very important. It can't just be done by a single person. It really takes the whole group. Establishing a safety plan, documenting the formal requirements for that machine safety plan, for the roles and responsibilities, who's going to be doing what, building competency, having rigorous documentation, and then doing audits over time to make sure that you are, checking progress, making adjustments where needed, and continuing to improve, continuing to build a better program. All of those are aspects of really building out that machine safety management system. Those are all goals or things that need to be in place to really say we've got a robust machine management program in place. If we look a little bit more at the specific documents in the machine functional safety plan, typically this will start out with a top level document that we call a machine functional safety management plan. So your top level requirements, what needs to be in place for competency, for independence, making sure that all of the phases of the life cycle are addressed, and then identifying a clear description of those handoffs between different phases, between different groups. Underneath that, we've got specific group procedures, which look at more detail of the process description for that relevant phase. So what is the process that we follow for a hazard and risk assessment? What is the process that we follow for identifying the safety requirement specification? So that's certainly something that we want to define that process, exactly what needs to go into it, what sort of outputs are expected, whether those outputs are generated by internal personnel or whether that is a step of the machine safety lifecycle that is delegated to a third party, a trusted third party, knowing exactly what that output should look like, what needs to be provided as part of it. And then lastly, on the project side, for a specific machine that's being implemented for a specific uplift or upgrade program, looking at the project plan, tracking each document for the project, the who, what, when, where, how, making sure we know, who completed a task, exactly what they did, when they did it, where it's stored, and how that feeds into the rest of the life cycle, tracking the sign-off. So all of that is really important to having a rigorous program and tracking all of that information. Within that top-level plan, we can think, like we talked about, identifying those top-level strategies, identifying the roles and responsibilities, making sure that the competency and training requirements are documented, how software and configuration is managed over time, identifying all of the specific lifecycle steps that will be followed, and then lastly, how the documents are managed, where things are actually stored, how do we enforce the policy, when we do periodic audits, are they working well, are they being followed? And again, really looking to continually improve that machine FSM plan. And so each of these components really are a part of that larger overall machine safety program. From a roles and responsibilities standpoint, we can think about each of the life cycle steps in the machine safety life cycle, everything from the risk assessment to decommissioning, and identifying for the site who is specifically responsible and accountable for that task, what other parties need to be brought in and consulted and informed. And the really nice thing about ERACE is it just helps make sure that we're not losing any communication from one step to another, that everything identified in the HARA is clearly communicated to the next person who's going to pick it up and be responsible for the SIL and PL determination, or that the correct SIL and performance level targets are given from the determination to the person doing the verification calculation. We need to make sure that that information flows from one step to the next. Another thing that's important to look at with the RACI aspect and the team aspect is that machine safety is really a team sport. And so if I go back to kind of my idiom for tackling machine safety and addressing the challenges, we can think about a football team, whether you're from the US or not from the US, tackling still involved, and it really does need to be a group activity. And if we think about it, a lot of sites that I've been to have what we call kind of the lone ranger, or the single person who's been tasked with safety as one of their activities, but it's further down on the list. And they may be a superstar. They may be doing everything they can to improve the safety of that site, increasing awareness, trying to document all of the changes. But if that one person moves on to a new company or a new role, the program totally falls apart, because things aren't documented consistently. The way one group does it versus another is not consistent. And so really, to have a robust program, you've got to have a team in place. You've got to have it documented. And it's only together pulling in all of the necessary groups, the operators, the maintenance technicians, the supervisors, the controls engineers, all of those personnel really have to work together in order to understand, implement, and comply with the machine safety program. And so that's one point I really want to highlight here. From the documentation side, just in terms of the logistics of making sure that the right documentation is in place, this is anything that's needed for the life cycle. So for each life cycle step or phase, the actual management program and procedures themselves, verification and validation results, and also the results of those periodic audits. So we have to track, we have to have all of that information. And then the mnemonics, to remember it, we use the 4 R's. So we've got to have the right data or the right information in the right format. So something that we can use, bring forward at the right time. So we have it at the right phase of the life cycle, the right phase of the project, and in the right place, stored somewhere, again, where people can find it, where it's known where the hazard information is, or where the safety function design is. So that's really critical, that people can access it and find it when needed. And I know even just myself with my own file folder structure, it can sometimes be a challenge. So when you've got multiple different people looking for things, it's really important that that is well defined and well documented. If we think about how we can practically do that, right? So we've talked about the goals, we talked about what's included, but how do we actually get there for a facility that may have 40 different documents already in various states of completion and various states of relevance, may have a lot of different operators with various level of training and exposure. And so these are some specific steps or some specific recommendations in terms of the how, or the practical side of building up a safety management program. So the first one, leverage whatever quality programs are already in place. If you've already got strong quality assurance procedures, leverage that and look at how to build safety into it. If you're a site that's got a mix of process and machinery applications, so a chemical facility with a large warehouse, power plants with some larger equipment, metal processing facilities are really interesting, where there's a lot of chemical process stuff going on in a steel processing plant or a steel mill, and then you've also got all of these large mechanical equipments for rolling, packaging, transport, all of that. So there are a lot of industries where there's actually a bit of overlap. And so for those, if you already have a process safety management plan in place, take it, build machine safety into it, look at where they need to be different, understanding the different machinery hazards, some of the different considerations, but build those programs together to really tackle both. Similarly, if a company's already using 62508 but has some specific machinery aspects they want to include in that, it is certainly possible to build the safety management plans together. Can think about that the management programs, not just the top level activities, but also the technical activities for the life cycle, and really defining what needs to be in place to achieve and maintain that safe workplace. Looking at the people, the departments, the organizations, who's actually going to be responsible for driving it, making sure that you have at least one or more lead machine safety personnel for each different activity, making sure that they have support and buy-in from the management and the supervisor team, and then developing your top level procedures, building templates that you can use for the different life cycle steps, and leveraging tools and basically things that are already there to make it as easy as possible to move from the starting point to the desired endpoint. So all of those things can help make it a little bit easier to get there. And then to follow continuous improvement with those periodic audits. Because it's not going to be a one step where you jump from where you are to exactly where you want to be. But having those audits over time, you can track progress, you can make sure that you're on the right track and getting better each year. And so in terms of the templates, and these are, pre-developed documents that can serve to really help get the process started. The IEC 62061 template set that Exida has developed is a mix of machine safety aspects for that top level machine safety management plan, as well as specific group procedures for the analysis, design, verification, and operations phases. And so in that top level functional safety management group, we've got the overall machine functional safety management plan. We've got project specific safety plan, ways for documenting the RACI charter in there, the competency evaluation procedure and log, tracking action items consistently, and also management of change again, which is a really critical one for making sure that we are managing changes to the safety critical system. And then from the group procedure side, looking at the specific steps from the hazard analysis and risk assessment all the way through design and the SIS maintenance plan to make sure that we're following the right steps for each of those phases of the machine safety lifecycle. And so when we look at these templates and think about how they can be beneficial or why would someone consider purchasing templates or using them as a starting point? So the first one is it just decreases the amount of time and energy it takes to build out the program. If you think about starting from a blank page as opposed to starting with something that is 80 to 90% of the way there, that is based on all of the relevant IEC 62061 requirements, that includes additional best practices, it just makes it a lot easier to make progress. It cuts down the amount of time that it takes to develop the program and can really increase the speed of deployment. Instead of taking a year or a couple of years to try to write out the procedures and not really getting traction, with a pre-developed set of templates, it's much faster to get it updated, to get it rolled out, and then make adjustments or improvements over time. Also, just in terms of the logistics of using them, they're designed to be easy to use, simple and consistent formatting so they can be moved into company-specific procedure formats, have a number of fields that can be quickly updated just once and then deployed throughout the entire document. So it really does just make it easier to make that progress toward improving safety. And so another thing to think about is, depending on where an organization is, there are different first steps to take. Some organizations may have, champions may have the knowledge in place and really just need a little bit of help getting started to really build out that program. So they're just buying the templates by themselves is a perfect solution, and that really fits in. Other companies, maybe aren't as sure or aren't as familiar with the background concepts. So going through training to really develop that, and then starting with the templates can work well. In some cases, companies want specific help, modifying, adjusting, and customizing the templates. So in that case, we can actually work with companies to use that template as the starting point and really customize it to them and their needs. So really, wherever you are or whatever you're starting from, there are ways that these can be leveraged and really used to improve that deployment of the safety management. And on the training side, we've got a number of online self-paced trainings through Exida Academy. The one I do just want to highlight here is that our FSE 110 Machine Functional Safety Engineering course is our 4-day full machine safety lifecycle course that I mentioned when doing the training back with the case study. So this is available online to get started in a self-paced format to start building those competency areas if you or someone else on your team is interested in getting more involved in machine safety. We have a number of other courses as well, including a variety of cybersecurity, alarm management, and other courses in addition to the functional safety. And then coming up, we do have a number of online and in-person course in Sellersville for a number of cybersecurity and functional safety courses through the end of the year. So just want to highlight those as well. And so if you enjoyed this topic, if you are interested in learning more about machine safety or other topic areas that Exida covers, please don't hesitate to follow us on social media. We try to do a couple of webinars each week. And then also, if you do have any questions that we don't have a chance to go through today, and I have seen quite a few questions come in, don't hesitate to send me an email, and I'll always be happy to get back with you as fast as I can on that. Okay. All right. So the first question I have here is, can you address the potential need to apply IEC 61508 as a user standard in handling low demand mode functions, and also guiding functional safety in the operations and maintenance phases? Yeah, so I think it is good to note that 62061 does cover both high demand mode and low demand mode, but there are some pretty explicit comments in there that say that it's really focused primarily on high demand. And if you've got questions on low demand, it does point back to 61508 and 61511. So certainly if there's a machinery application where a lot of the safety functions are low demand mode as opposed to high demand mode, it certainly would be very beneficial to fall back to 61508 and look at that in terms of best practices for handling low demand mode. So certainly that's a logical step there. And then for the second piece on operations and maintenance phases, again, definitely agree that if we think about it, 62061 is the application standard back to machinery, and 61508 is the parent standard. So it has a bit more detail, a bit more meat on it for functional safety overall. So for that operations and maintenance phase where machinery standards tend to be a little bit later, falling back to 61508 and some of the more detailed requirements there absolutely makes sense. And I'll say in the way that the 62061 template set is built out, for those areas on proof testing and the maintenance requirements, Exida internally, we really see that 61508 and some of those 61511 requirements as best practices that should be met and should be followed and considered. And so we've built some of that into the templates as well to really show what a more robust maintenance and operations phase approach would look like. Okay, so the next question I have here is there a difference between proof testing and functional testing for SIF loops? And is there a simple diagram in an animation to show the differences? So I'd say I don't have an animation off the top of my head, but I've got a couple, I think, good examples that can help to illustrate the differences. So the first is a lot of the times a functional test might be done just to show that a safety function works, whereas a proof test is specifically trying to find any undetected failures in the safety system. And if we think about what that really means is, let's imagine that we have let's call it a two-hand control set point where we've got to depress two levers, and if both of them aren't depressed, then we don't allow the drilling operation to continue. For a functional test, we might press both of the controls down and wait to see whether or not the system actuates or operates. But for a proof test, we might first try just one of the levers and see is everything connected properly, or have the contactors for the other push button welded shut, where just pushing the single control allows it to go. And we might do that and try each one independently, and then test the overall safety function to see that it's working. So that's just one example. A lot of times that can come into play with sensors as well. So looking at if you've got multiple pressure or proximity sensors, making sure that both of them are still functioning correctly, making sure that the logic works properly with all of the voting. And then from the final element side, if we think about contactors or something where we are cutting power, again, if we have two contactors in series, just seeing that the power has been cut says that overall our safety function was successful, but are both of the contactors working or is one of them welded shut? So really trying to understand any ways in which the system might have failed is more of the objective of a proof test as opposed to just seeing if it works. Okay, excellent. So it looks like those are the questions that we have from this session. So again, if you do have any other questions, don't hesitate to send them over email. And thank you everyone very much for your time today. We look forward to seeing you on another webinar soon.